What's up, people? We are proving discontinuity. So taking a look at our first example, I'm asked to prove that the function is discontinuous at 3. So um, the way we're going to do that is we're just going to run down our conditions of continuity, and if one of these doesn't end up being true, then I know it's discontinuous. All right, so I noticed that I can factor this, so I'm going to go ahead and do that because I'm probably going to have to later anyway. So I know this is x minus 3 and x plus 2 over x minus 3. I know that'll cancel. So I get x plus 2, but x also cannot equal 3. Okay, so I'm just going to test this first one here, saying that the limit exists. So let's test if the limit exists. All right, so the limit as x approaches 3 of f of x. Well, for my limit, I can plug in 3, and if I plug in 3, I get 0 over 0, meaning I can do something else. So I guess that's why we went ahead and factored. I can plug 3 in at this stage right here. That's okay for limits, and I'll get 5. Right, so my limit does exist. Okay, let's check if the function is defined. Well, obviously it's not. Okay, if I take f of 3, I get 0 over 0, which is no bueno, undefined. Right, so therefore, f of x is discontinuous at x equals 3. Okay, if we want to draw a graph, we definitely do. Okay, I know that I cross at -2, I go up to 2, and then 2 and 3, I got some points going on there. So I'm going down, it's linear, going up, 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 until I hit 3 and I have a hole. Right, that's what that function will look like. All right, let's do another one. So again, I'm using the definition of continuity to prove that this is discontinuous at 0. All right, so let's run through it again. First, let's prove that the limit exists, and in order to do that, I got to do the left and right-handed limits. So the limit as x approaches 0 from the left, well, that's going to use this top function here. And the limit as x approaches 0 from the right, that's going to use that bottom function. All right, so if I plug in 0, I get 2. If I plug in 0 here, I get 1. These are not the same thing, so my limit does not exist. Okay, I can say that my limit from the left of f of x does not equal the limit from the right of f of x. Hey, no good. So therefore, the overall limit as x approaches 0 of f of x does not exist. Therefore, I can say f of x is discontinuous. All right, once again, let's give this a graph. All right, so top function, linear. I know that it's negative and it has a y-intercept of 2, but it stops there. Okay. Okay, it stops there. And this is a quadratic at 1, and it does not exist at 1. This does exist at 2. Right, these do not touch, no good happening there. All right, last thing, use the definition of continuity to find k. So again, I'm forcing this to be continuous. So I need to use the idea of left and right-handed limits. So I need to evaluate 2 from the left of f of x, and I need to get 2 from the right of f of x. All right, 2 from the left, that's going to use this bottom function here. So that's going to be 8 times 2 minus k. 2 from the right, that's going to use this top function here. So that's going to give me 2 squared plus 2k. All right, now I know that these need to be equal to each other if it is to be continuous. So I know that 16 minus k has to equal 4 plus 2k. All right, now I can just solve for k, so I can bring this over. 3k equals 12, so k equals 4. Right, so that means that my new function, f of x, is really x squared plus 4x, and then 8x minus 4. And I got these conditions here, squiggly. And that is all for today. I will see you all later.